Hi guys, in this specific discussion we're going to look at the equation of a line, and that is going to be the equation of a line in three-dimension space, and this is going to give us a clue on how we can be able to of course give other equations of various aspects like the planes etc. So in today's discussion we're going to consider a general case of a specific line, and of course we're going to use the Cartesian coordinate system in assisting us trying to find a general way in which we can be able to describe an equation of a line. So I'm going to give an illustration on the board that is going to assist us, of course, achieve the same. So in this specific discussion, we're going to exploit the concept of parallel lines, and perhaps we're going also to look at the concept of a norm and other aspects of vectors that we have discussed. So suppose we have I have a point that lie, or 2 points for P and Q that lie on the z-axis, if I can give it in terms of this specific values, and this is the origin. So suppose I have this particular point that is has a value of 2 and 4 on the z-axis. I can be able to describe point Q or P in terms of or rather I can be able to describe point P in terms of Q by giving as Q is equivalent to 2P, and that is going to be true for that, because if I substitute P for 2 here, this is going to be equivalent to 4. So the coefficient of 2 gives a relationship that exists between Q and P, and therefore I'm going to use that specific concept for our case here in trying to find the equation of a line. Now suppose I have 2 points lying on this specific line that I can give in terms of L, which is point P0 and point P given as such. I can be able to give the coordinates of point P as x0, y0 and z0 given as such. And for this one, it's going to be x, y, and z given as such. So those are 2 points on that specific line. And I can be able to do an extrapolation over this specific line for the z x-axis, the negative x-axis from this point. Let's assume this is the origin. And obtain another vector v, of course, which we can be able to give as such. So if I give this vector the coordinates of A, B, and C, I will describe it as a vector, a non-zero vector, which is going to consist of a V that can be described as a VB, A, and C. Then therefore, I can be able to establish a relationship that exists between this vector and that specific line there. And that is going to assist me, of course, try to define that equation over that specific line. So first I'm going to have this specific line which is parallel to that vector which is P, and then we're going to see that from this specific perspective and from the analogy that I've given in this left part of the side, I can be able to describe these two lines in terms of course what we have referred to as the scalar quantities, or rather I can be able to define them in terms of vectors, and say that vector POP is parallel to this particular vector V. But since I've said that there's going to exist a scalar multiple which is going to assist me obtain this point V. So V is a multiple, aside given for 2 and 4, it's a multiple. PB, which is a vector, is going to be achieved by multiplying vector V by a particular scalar, which is going to be given as T. So therefore, this is going to be achieved by that specific product, and therefore we can be able to give this one in terms of these particular differences for vectors as I've done in our first case, whereby we're going to see that we can be able to illustrate x. So this is x minus x naught, y minus y0, and then z minus z0. And then this is going to be equivalent to the multiple of that vector v being given by this scalar, and then A, B, C given as such. So then therefore I can be able to expand this right part of the equation by having TA, TB, and TC given as such. So this portion of the equation, which is a P0P vector, is going to be equivalent to this second part of that one that is down there. So in trying to look at the various terms of this specific equation, I can be able to equate this first part of x minus x0 equivalent to TA, and then y minus y0 equivalent to tb, and z minus z0, which is equivalent to tc, respectively. So these are going to give me what we call three equations, which are going to be parametric equations, which are going to give me equations with that specific scalar t, which is going to take a value for those parametric equations of t. So therefore, I can be able to make, if I give this one in terms of y, so I can be able to make this one x the subject of that formula. X is equivalent to x naught plus ta, y is equivalent to y naught plus tb, and z is equivalent to z naught plus tc, respectively. So if I try to look them from this specific perspective, we're going to see that the scalar for t is going to range between positive and negative infinity, given as such. So I can just leave it as negative infinity and positive infinity as such, and which we said can take another value. So these are going to be the parametric equations of this specific line that I've given in this specific case. So we can look at a general example, and of course, which is going to give us a clue on how we can be able to interpret the concept of a line in three-dimension space. So I'm just going to read the equation so that we can be able to just extract the information and of course do the necessary as we have done for this in the equation of a line. So it states that find the parametric equation of a line passing through the points. So we're going to have point B0 given with the coordinates of 1 to -3, given as such, passing through a point B0 and parallel to the vector. So this is going to be parallel to the vector which is going to be given as v, which is v given as 4, 5, -7 as such. So this is of course a point that is parallel to this specific vector. So he said we can be able to have a general point, of course, for a p, which is going to be given as x, y, and z on that specific plane. So therefore we can be able to have, or that specific line that we can be able to give as L. So we can have that line as having point P0 and P given as such. So the vector PP can be able to be represented in this specific case as the difference between x minus 1, and then this is going to be y minus 2, and then we're going to have, this is going to be z minus 3, so that is positive 3. So this is going to be a representation of the vector PB, and then we're going to see that for us to obtain the equation of this specific line, we're going to have the vector PB being expressed as a multiple of that specific vector that is given as vector P, which is parallel to that specific line, and then we can be able to give this scalar quantity for t particular value. So we had said that t can range between negative and positive infinity, and therefore we're going to give a general equation for that by equating this. So we're going to have this one equal to t, and then we have values for t which is 4, 5, and -7 respectively. So this is going to be equivalent to t4 or 4t, and then we're going to have this one as 5t, and then we're going to have this one as -7t respectively on this other side. So implying the value for x can be obtained by equating this x minus 1, which is equivalent to 4t. So therefore implying that x is equivalent to 4t plus 1. So that is the first case. And then we're going to have the value for y given as y minus 2 is equivalent to 5t. So implying y is equivalent to, so we're going to take this, so 5t plus 2 given as such. And then lastly, we're going to have the value for z, which is z plus 3 being given as -7t. And this is going to be equivalent, so the value for z is going to be equivalent to, this is -3, -7t given as such. So that's how we can be able to obtain the values of the parametric equations for that specific plane, which we have been given using that specific example. So in this case, I hope that this, together with the first one for the expression of our equation for our plane, are going to assist us in trying to give those specific aspect for the equations in three-dimension space, respectively. So that is it for now, guys. Kindly subscribe to our channel and follow us in the comment section so that we can be able to have a healthy discussion and assist us find various other ways we can be able to achieve these specific objectives together, especially in trying to tackle the equations or the questions that we come across, especially in mathematics, physics, chemistry, and biology. So that is it for now, guys. Bye. God bless.